Hey everyone, so today we are going to continue graphing, but no more table. The table is a little tedious, so we're going to go through and graph using some other information. So I want you to start by this is an SAT question. Notice you should know how to do it, hopefully looking at the answers. So again, the SAT, a lot of the questions are very straightforward, things we learn in class. You just have to learn it, right? All right, so pause and get the answer. So this is quadratic formula. You notice the square roots everywhere. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so we get negative 12 plus or minus all over 6. Let's see what we get under that square root. All right, so we get 72. So notice that's not one of the options because we can simplify 72. What perfect square goes into 72? Well, if you're having trouble, notice, look at the answers. They all have a 2. Most of them have a 2. So my guess would it be it's 2 times something. 2 times what is 72? 36. Perfect. Put the square roots around it. Square root of 2 is just the square root of 2. Square root of 36 is 6. That goes in front. So we get negative 12 plus or minus 6 root 2 all over 6. And then we have to divide, right? So negative 12 divided by 6 is negative 2. 6 divided by 6 is 1. So the answer is A. All right, so just a little quick review of the information we know about a parabola. So what is this point right here? Let me grab the little. What is that point right there? That's the vertex. Remember that's called the vertex. So let's label that on the picture. There's my eraser. And then what would be this point and this point? That's where it crosses the x-axis. So that's called the x-intercepts. X-intercept, x-intercept. And then this point right here would be what? Well, that's where it's hitting the y-axis. So that's the y-intercept. And the last one's that dotted line. What's that dotted line? That is your axis of symmetry. All right, so remember, the y-intercept is always your c value, because if you plug in 0 for x here and here, you're just left with c. So whatever the c value is, that's your y-intercept. To find the vertex, we use that formula, negative b over 2a. That gives us our x. And then we plug in to get the y value. That's how we find our vertex. And then last, to find the x-intercepts, that's where y equals 0. And then all we're going to do is have 0 equals, right? And we learned how to do that. So we factor, we use square roots, or we use the quadratic formula. All the problems we're going to do today, you can factor. All right, so let's do this. Instead of making a table, we're going to use our other skills. So start by finding the x-intercepts. So 0 equals x squared minus 6x plus 5. All right, so pause the video and factor and solve. So I'm going to go down here where I have some space. I'm multiplying to 5, combining to negative 6. That's 1 times 5. Make them both negative. So we get x minus 1 and x minus 5 equals 0. So then I solve. Plus 1 and plus 5. X equals 1 and x equals 5. All right, so we get x equals 1 and x equals 5 are my two solutions for my x-intercepts. So now we're going to find our vertex. So if you haven't already, do that. That's our negative b over 2a. So we got negative b, negative 6 over 2 times 1. So that's 6 over 2, which is 3. So 3, comma, and then we're going to plug the 3 in. So 3 squared minus 6 times 3 plus 5. You can use your calculator. So I got -4 when I plugged that in. The y-intercept, remember we just said before in that last slide, oops, the y-intercept is our c value, so 0, 5. All right, so let's plot that right now. So right now we have a bunch of information, so let's start with that. And then we'll go and do the symmetric point. So I have my x-intercepts on the x-axis. I go to 1, and I go to 5. 2, 3, 4, 5. So I've got those points. And then I have my vertex, which is 3, -4. To the right 3, down 4. 1, 2, 3, 4. And then I have 0, 5. 1, 2, 3, 4, 5. All right, so now the symmetric point is of the y-intercept is if we reflected over the axis of symmetry. Remember the axis of symmetry goes through here. So if you notice, how far away is my y-intercept from my axis of symmetry? 1, 2, 3. So then we're going to go 3 more. 1, 2, 3. So this is our symmetric point. It's right here. So it's 3 away from our axis of symmetry. So then we go 3 more, right? Because symmetric, it's the same distance away. So you did that in pre-algebra. Probably 8th grade. All right, I'm going to erase those, and now I'm just going to draw my graph. So if we write down what that point was, that point ended up being 6, 5. So the y value is always the same because we're just going horizontally to the right, and we double the vertex. So this is 3, so we just go 3 more. So that's a really quick, easy way to remember it. We just double whatever our vertex point x value is. Okay, so let's write down a little bit more. We don't really use the term x-intercepts a lot with parabolas. We actually use 2 other words. We use the zeros because it's where y equals 0. And the one I use the most is the roots. I like to think about it is I have a graph, and then the roots, if it's like a tree, right? The roots are where it goes underground. So it's where this thing goes underground. And then we talked about the symmetric point, so let's write down how to find it. So for our symmetric point, the y value is exactly the same as the y-intercept, but to find the x, we double the x value of the vertex. It has to do with the symmetry that we're the same distance away from the axis of symmetry. Okay, so same thing. We're just going to use these 4 things to find our graph. So start with the vertex, then we're going to do the roots, that's factoring and solving, y-intercept, and then we're going to figure out the symmetric point. Now notice I didn't give you a normal graph because the points are going to be a little too big to fit on a 10 by 10 graph. So I'm going to go over how I want you to do this on the graph, all right? Okay, so pause the video and find all our important information. So I have my negative b over 2a. So negative b over 2a. So that's 7 over 2, which is just 3.5. So I'm going to do 3.5, comma. Now I'm going to plug in 3.5. 3.5 squared minus 7 times 3.5 minus 8. And just plug it in the calculator. You don't have to go crazy with it. So when I plug in, I get negative 20.25. And so you'll see that's why I didn't give you a regular graph. All right, so roots. Roots are where we factor and solve. So we are multiplying to negative 8, combining to negative 7. 8 times 1, where the 8 is negative. So x minus 8 times x plus 1 equals 0. X minus 8 equals 0. X plus 1 equals 0. So we get x equals 8. X equals negative 1. And then our y-intercept is just where this thing crosses the y-axis, is our c value. All right, so we'll do the symmetric point in a second. So when I do these, we're in high school. The higher up in math you get, the less specific you need to be on your graph. So what I'm going to do here is I'm not going to go crazy. I'm going to go on here and I'm going to start labeling. So I know I need to go down to -20. So I'm going to go -20 down here. I need to go to the right to 8. So I'm going to make that an 8 and then that a 4, that a 2, 6. I need, make that -2, so that's -1. My y-intercept is -8. So if that's -10, this is probably -8. That's good. So then when I go through, I'm going to plot my 3.5, -20. So that's like around here. And I'm going to label that as 3.5, -20.25. I got my -1. I got my 8. I got my -8. I'm going to draw this in the best I can. And then how do we find the symmetric point? So remember, we double the vertex. So if we have 3.5 and we double it, we get 7. And then the y is the same as the y-intercept because it's the symmetric point of the y-intercept. So we get that point around here. Right, that's it. So notice that I'm labeling enough so that I know what these points are. What I don't like, you can't just, if you on your homework just do like that, that's not helpful to me. I need some dashes. You don't have to put every single number in. Notice I did skip a lot, but I put the important numbers in. And then for the vertex, because it had those decimals in there, I did label what that point is. So on problems on your homework like this, I want you to label somewhat. Don't go crazy with it. If you're going up to 37, you don't have to put all the way to 37. Like 1 through 37, that'd be terrible. But you need to at least label somewhat so I can tell that you know what you're doing. All right, the rest of these today are stuff on regular graphs. All right, so pause and do these. All right, I reordered the vertex and the roots, so you can do it in whatever order you want. So for the roots for this one, to factor this, remember it's 0 equals 2x squared minus 8x. That's a GCF. That's a GCF of 2x. X minus 4 equals 0. So we get x equals 0 and x equals 4. Right? 2x equals 0. Divide by 2. And then x minus 4 equals 0. Add 4. For my vertex, negative b over 2a. So the b value in this case is -8, 2a. So that's 8 over 4, which is 2. And then I plug, so my vertex is 2, comma. Plug that in, 2 times 2 squared minus 8 times 2. Plug that in your calculator, and you get 8 minus 16, which is -8. The y-intercept. Our y-intercept is our c value. What's the c value here? Well, it's not there. So what is it? 0, 0. When it's not there, it's just 0. The symmetric point, remember we double the vertex. So the vertex was 2. Double it, we get 4, and then 0. So actually notice, what do you notice? The roots and the y-intercept and the symmetric point, they're all the same. So we have a bunch of repetition here, but that's okay. So my roots are 0 and 4. My vertex is 2, -8. My symmetric point, again, is 4. My y-intercept is 0. So there's only 3 points here, and that's okay. That happens sometimes, especially if we can't fit stuff on our graph. That's our graph. And then remember, the axis of symmetry is x equals the x value of the vertex, 2. Okay, same idea. This one, like before, the vertex is going to be a fraction. So don't freak out, though. It's okay. Go through, find your roots, factor and solve, vertex, do all the things. All right, so my roots multiply to -6, combine to 1. That's -2 times 3 is 1, so x minus 2, x plus 3 equals 0, x minus 2 equals 0, x plus 3 equals 0. Add 2 to both sides, so we get x equals 2, minus 3 on both sides, x equals -3. So x equals 2, x equals -3. Vertex is our -b over 2a, so we are going to get a fraction here because our b value is what? -b over 2a, our b value is 1. So -1 over 2 times 1 is -1/2. So -1/2, comma, now we got to plug -1/2 into the equation. I got -6.25. So -6 1/4. My y-intercept, again, my c value, 0, -6. Symmetric point, we're going to double the vertex. If you double -1/2, you get -1, and then the y value is the same. X is a symmetry, x equals, again, that x value, the vertex pops up a lot. All right, so let's graph this. So I have +2, -3, -1/2, 6.25. So we're just going to do the best we can with this. Looks like it's about here, right? And then 0.6 is really close. -1.6. So all those points are really, really close together. And then we're going to connect the dots, make it a nice graph. Now, one thing that I want to bring up is make sure when you're drawing this, it makes sense. So let's say I've seen students where they have this, but then they messed up. Say you put it 1/2 instead of -1/2, and it's over here. If you're trying to draw a parabola and it's like weird, like it's off, where it's skinny on one side, but then it's like off on the other, you probably messed up a sign. So pay attention to that. As I've also seen students do like the vertex, the roots are here and here, but then their vertex is like over here. So that's not a parabola. So you clearly did something wrong. So check your signs if that happens. All right, getting to a hard one. Now this one's challenging, not because we don't know how to do it. It's really when the factoring is a little harder. This is a slide. So if you are not comfortable doing a slide, you could always do the quadratic formula. It's up to you. I am giving you one that is factorable. This is a slide, but if you would like to do the quadratic formula, go for it. So pause, and again, do all those things that we know how to do. So to factor this, multiply to -24, combine to 2. So that's 4 and 6, where that 4 is negative. So then remember, we put the 3x in front for both of them. 3x plus 6 equals 0. And then we divide by the common term. So we have that 3 there. So 3x minus 4 times x plus 2. Set those equal to 0. So here is the easy one. We get -2. This one on the right, though, remember we have to add 4 to both sides. So 3x equals 4. And then divide by 3. So 4/3. So we get x equals -2 and x equals 4/3. All right, vertex, -b over 2a. Again, we're going to have a decimal. So -b, -2 over 2a. That's -1/3. Please don't put it as -0.3. You're going to just, because if you plug in -0.3 into the equation, your answer is rounded too much and it's going to mess it up. Please leave it as a repeating. Unless it's like really crazy, I would prefer a fraction. Just when you're plugging in at least, because you're going to mess up your final answer. I had students in my advanced class do that, and their answers sometimes your answers are like way off. So I get -8.3 repeating, so -8 1/3. So you can put it as a mixed number, negative 8.333, however you want to write it. I'm okay with decimals here. I just don't want you plugging decimals in. So if you put negative 8.33, that's fine. Y-intercept, 0, negative 8. If you double a third, what do you get? 2/3. Remember, 1/3 times 2 is 2/3. All right, let's graph this baby. Negative 2. 4/3 is 1.3 repeating. So 1 and a little bit. So just do the best you can with it. Negative 1/3, negative 8/3. So we're like here. 0, negative 8. These are always so close together with these. So we have another one where those 3 points are like right on top of each other. Doot. And there's my graph. And then the axis of symmetry, x equals the x value of the vertex. All right, last one. Solve it. Do all the things. Alrighty, so this is another slide. So we are multiplying to negative 10, combining to 3, right? Negative 2 times 5. And it's 2 and 5, where the 2 is negative. So negative 2x minus 2, negative 2x plus 5, divide by negative 2. So x plus 1 times negative 2x plus 5 equals 0. X equals negative 1. And then here we get negative 2x plus 5 equals 0. I'm going to subtract 5 on both sides and divide by negative 2. So notice those negatives go away, so we get 5/2. So x equals negative 1 and x equals 5/2. 5/2 is just 2.5. So feel free to put 2.5 there. All right, vertex. Negative b over 2a. So those negatives again go away, and we get 3/4. 3/4 is 0.75, so if you want to put 0.75, it's a decimal that ends, go for it. Plug in all that in the calculator, and I get 6.125. So 6 and an eighth. All right, 0.75, 6.125. Y-intercept, 0.5, our C value. Symmetric point, if we double 0.75, what's that? If I have 75 cents twice, I have $1.50. So 1.5 comma 5. Axis symmetry, x equals, again, that vertex. All right, let's plot these. Negative 1, 2.5, 0.75, positive 6.125. This thing's upside down. How do we should know it's upside down when we look at it. How do you know that? Negative 2, it's negative. My y-intercept is 5. Oops, my pen turned off. And 1.55. That looks good, right? Those look like they're the same distance apart. And then I'm graphing it. That's it. Here's my parabola. So again, I like this method. This is probably my favorite method because it's using all the information that we know. It really kind of encompasses all the information we know. Factoring, solving, finding the vertex, y-intercept. I really like this method. All right, so that's it. Practice. I'll see you later.